So today we are going to start with the differentiation and integration. To understand maths is very important because physics is actually based on mathematics. You can understand that mathematics is the language of physics. With the help of mathematical tools, you can easily analyze physics in depth. You can analyze the laws of physics quantitatively and qualitatively in a better manner using mathematics. So, in the beginning, we are going to start with the differentiation. Differentiation. What does differentiation do for us? Differentiation is used to calculate instantaneous rate of change of one variable with respect to some other variable. That is, differentiation is used to calculate the rate of change instantaneous. Instantaneous word is very important. Those rate of changes are two types. For example, let's say if I talk of average speed, then we all know that average speed is simply what distance covered upon time taken. But when this time taken delta t becomes very small, tending to zero, then this average speed will get converted into instantaneous speed. That is, this time difference goes very small, this delta x will also become very small, and this quantity, when these two quantities are very small, then it can be represented in this manner. dt is a very small time change, and dx is the corresponding distance covered in that very small time change. So this dx by dt is simply the instantaneous speed at a particular instant. So differentiation is used to calculate such instantaneous rates of changes. We have to just learn how to do differentiation. What are its some basic uses in physics? So if somebody asks you, to differentiate a function with respect to some variable, then how will they ask you the question? So we should know about the symbols for differentiation. There are many symbols used for differentiation. Let's say we have a function y is equal to fx. Y is equal to fx is a function like, for example, y is equal to 2x square, or y is equal to sin x, or maybe y is equal to cos x or anything else. So if somebody asks you to differentiate this function fx, that is 2x square with respect to x, then the guy will ask you to find this. It means you have to differentiate 2x square, which is y, in fact 2x square with respect to x. You have to differentiate 2x square with respect to x. You have to differentiate sin x with respect to x. So this is the first symbol for differentiation. Second, maybe to find y dot. Third, maybe to find y dash. Or then I may ask you to find y dash, that is f dash, or maybe f x dot. All these five are symbols used to find differentiation, right? And now what we are going to do is we are going to understand some standard differentiations which we all have to remember. Some standard differentiations. We all have to remember all these differentiations. These are 11 basic standard differentiations which we have to remember. Like if somebody asks you to differentiate a constant number. Constant number means like 2, 3, root 2, root 3, pi. All these numbers are constant numbers. If you differentiate any of these numbers or any constant number, then you will get 0. Second, d by dx, that is differentiation. It is read as this, d by dx. Not we can't just cancel out these d and d. You should not do that. Differentiation of x to the power n, x to the power n will be something like n x to the power n minus 1. For example, if I differentiate x square, I'll get 2x. If I differentiate x cube, I'll get 3x square. If I differentiate x to the power, then I'll get n, that is 4x to the power 4 minus 1, that is 4x cube. If I differentiate root x, then I'll get 1 by 2 root x. If I differentiate 2x, then I'll get 2. If I differentiate 3x, then I'll get 3. You have to remember these some standard examples so that you end up doing the things in a very short time. Also, if I differentiate 1 by x, then I'll get minus 1 by x square. So all these 4, 5, 6 differentiations need to be remembered to just increase your speed, calculation speed. So here we have seen just two standard differentiations, that is differentiation of constant is 0 and differentiation of x to the power n x to the power n minus 1. Now we will deal with the third standard differentiation, which is, let's say, d by dx of e to the power x. Differentiation of e to the power x is e to the power x, say d by dx of a to the power x is a to the power x ln a. For example, you might not be very much friendly with log kind of things. So, for example, if somebody asks you to differentiate to the 2 to the power x, then you will do it like this: 2 to the power x ln 2. So this is the differentiation of 2 to the power x. Fifth is, let's say, d by dx of ln x is 1 by x. Remember this thing that ln x means log base e and x. If in physics you find somewhere written log x, then this implies log 10 base and x. So here we are differentiating ln x, that is log with base e. Till now we do not know how to differentiate log x or log with base 10 x. We don't know how to differentiate this, but we know the differentiation of ln x as 1 by x. The differentiation of log x can be done after converting this log into ln, right? That we'll do later in some question. Sixth differentiation would be d by dx of sin x is equal to cos x. D by dx of cos x is equal to minus sin x. dx of 10x is sec square x d by dx of cot x minus cosec square x d by dx of sec x is equal to sec x 10x d by dx of cosec x is equal to minus cosec x cos x. So you have to just learn all about standard differentiation. If you learn all these standard differentiations, then you'll get a good speed and you won't get stuck anywhere, right? So you have to learn all these standard differentiations, right? After remembering these standard differentiations, I'll tell you some rules to differentiate various functions. In next video, we'll see how to use those rules to find differentiation of any function.